Today we're going to look at scientific notation. Scientific notation uses powers of 10 to express decimal numbers. This came about when scientists were working on numbers that contain a vast amount of zeros in the number, and instead of writing zeros multiple times, they came up with another way to write the number, a little faster and easier way to write it. The form for scientific notation is n times 10 to the x. What's really important about this form is that the n has to be, okay, and I'm highlighting it so that you really see it, has to be greater than or equal to 1 but less than 10. So it can be 1, 1.1, 1.2, 2.3, 6.9, 9.999. It just can't be less than 1 and it can't be 10 or greater. So you have to be really careful about that. Okay, with that being said, let's take a look at what else it has to say here. Numbers more than 1 will equal a positive exponent. Numbers less than 1 will equal a negative exponent. For example, 34,000 is a number more than 1, so it's going to have a positive exponent. So to write it in scientific notation, we actually move the decimal point so it fits the criteria. Well, first thing you have to figure out is where the decimal point is in the number if it's not given. And you're right, it's at the end. So you put it at the end, and then you keep moving it until it fits the criteria of a number greater than or equal to 1, but less than 10. And as I move it, I find that putting it right there would be 3.4, which fits the criteria, and it took me 4 times to move it to get to that position, so therefore it's 3.4 times 10 to the 4th. Let's take a look at the next one. 0.007, it's a number less than 1, so it's going to have a negative exponent. Again, I have to move the decimal point until it actually fits the criteria of greater than or equal to 1 but less than 10. So as I move it to 3.7 doesn't, but 7 does. So it took me 4 spaces to move it to get there, which means it's 7 times 10 to the negative 4. Negative 4 because the number started off as a decimal number, less than 1. All right, let's take a look at what else it has here. Decimal form. So now we're going to go the other way. I'm going to give you the scientific notation. You're going to give me the decimal form. Positive exponents means you move the decimal point to the right. Negative exponents means you move the decimal point to the left. Well, this is a positive exponent, so I'm going to move the decimal point 4 places to the right. As I do that, whoops, let me get on my pen here. 1, 2, 3, 4, which means I'm going to have to annex or add 2 zeros to get my final answer. For this number here, 8.4 times 10 to the negative 6, because it's a negative exponent, I've got to move left 6 places. Well, 1 place is in front of the 8, 2, 3, 4, 5, 6. So I'm going to have to annex or add 5 zeros to end up with this answer here. Okay, let's go on to the next page and see what else we have to talk about. Write the number in scientific notation. Okay. We want to make sure that it is a number that falls in the category, has to be, and we'll write it up here for ourselves, n has to be greater than or equal to 1, but less than 10. Okay, so it's some number times 10 to some power. So we're going to figure out the number. The decimal point in 4.23 is at the end. If I move it once, it doesn't fit it. Twice, it does. So it's 4.23 times 10. It took me 2 places to move there to the second power. It's a positive 2 because it's a number greater than 1. All right, 2 million. Put the decimal point in at the end. It's some number times 10 to a power. If we keep moving that decimal point till we get to 2.00000, my answer will be 2 times 10 to the 6th power because it took me 6 places to get there. Okay, now we have a decimal number. So instead of moving the decimal point left, we're going to move it to the right. So it's times 10 to some power, and I know the power is going to be negative because it's a number less than 1. If I move it once, no. Twice, no. 3 times, no. 2.4 fixed the criteria, so 2.4 times 10 to the negative 4th power. This one again is times 10 to a negative exponent because again it's a number less than 1. I'm going to move the decimal point once. It doesn't fit the criteria. 2.67 does fit the criteria, so it's going to be 2.67 times 10 to the negative second. Remember, if I would have moved it one more place, 26.7 would not fit the criteria of being greater than or equal to 1 but less than 10. All right, now they're going to ask us to write in decimal form. So it's a positive 7, which means I'm going to move the decimal point to the right 7 spaces. So if I move it 7 spaces from where it is, it's 1, 2, 3, 4, 5, 6, 7. I'm going to have to add 4 zeros. So I have 1, 0, 4, 5, and 4 zeros. Now I will put my actual commas where they belong. And there's my answer. Let's do number 6. I'm going to have to move that decimal point out 8 spaces to the right. So 1 is behind the 7, 2, 3, 4, 5, 6, 7, 8. So I'm going to have to add 7 zeros. Let's put our commas where they belong. And there's my answer. Let's do a few more here. Okay, it's a negative exponent. So with a negative exponent, we're going to move to the left 2 places. So we've got 1, 2, so it's 0.010. It's a negative 8, so we're going to go 8 places to the left, so 1 is in front of the 9, 2, 3, 4, 5, 6, 7, 8. So I'm going to have to add 7 zeros, 2, 3, 4, 5, 6, 7, 9, 2. So really it isn't too bad. You just have to remember which way you're going and what kind of number you have, and you have to remember when writing scientific notation what your number has to be. All right, perform the indicated operations and write the results in scientific notation. Well, it's multiplication. So basically with this multiplication, I can actually multiply the 2 actual numbers on my calculator and end up with 4.14 times 10. Because I have a common base, I can add the exponents and get to the negative second power. Or I could have actually put it in my calculator and then change the answer to scientific notation. Whichever is better for you, you're more than welcome to do. Again, with number 10, because I have common bases, I can actually divide 5.2 by 1.3 in the calculator and end up with 4 times 10 common bases, so I can subtract the exponents to the second power. Now I'm doing adding and subtracting. Adding and subtracting are a little different. You have to have like everything, like terms in order to add and subtract. And if I take a look at number 11, I have times 10 to the 20 and times 10 to the 21st. So now I have to think, can I actually change one of them? Well, the way to do this is to change the bigger exponent by moving the decimal point one way or the other. If you're going to try to get that bigger exponent to go down, you're going to move the decimal point to the right. So I can actually rewrite this as 2.4 times 10 to the 20th plus 45.0, or I could just say 45 point times 10 to the 20th also. Now if you take a look at it, let's make that a 20. I have like terms. So I actually can add them. 2.4 plus 45 gives me 47.4 times 10 to the 20th because they are like terms. It's like having 2.4 A's plus 45 A's. That gives me 47.4 A's. But in this time my A's are times 10 to the 20th power. Okay, again, let's take a look at number 12. In order to do this, you have to have like exponents. And because it's subtraction, I don't have like exponents, so I don't have like terms. You go with the bigger of the 2 exponents, and to bring it down, you move the decimal point. Well, this time I need to bring it down 2 because I want it to go to 13, and it's at 15. So if I move the decimal point 2 places to the right, I end up with 142 times 10 to the 13th minus 2 times 10 to the 13th. Now I have like terms, so 142 minus 2 gives me 140 times 10 to the 13th. But now I got to take a look at my answer. And I have to take a look at both answers for 11 and 12. Both answers have to be written according to the directions in scientific notation. Now number 9 is, number 10 is, but number 11 and number 12 are not. You may think they are, but they're not, because they don't fit the criteria of n having to be greater than or equal to 1 but less than 10. So with this one, I'm going to move the decimal point once to the left. So now my answer is going to be 4.74 times 10 to the, you're right, 21st power. So that's my final answer. For this one here, I'm going to move the decimal point 2 places to the left. So my answer is going to be 1.40 times 10 to the, and if I go 2 places, it's going to give me to the 15th power. So basically, I'm going back to the actual bigger exponent once I'm able to combine like terms, and then I have to relook at my answer to make sure it's in scientific notation. Okay, that does it for today. If you have any questions, bring them to class tomorrow.